All right, let's dive into some pretty cool math today, I think. We're going to be talking about infinite sums.
Infinite sums.
Yeah. And you know what? Our source material, this video from Temsciência, I think it's Portuguese, for their science, it claims.
Oh, cool.
Yeah, that we're about to uncover like a hidden truth about math, which is that sometimes the order you add numbers in actually does matter.
Whoa.
Which is kind of crazy, right? Because
Yeah.
everything we learned back in grade school, about addition,
Right.
it might not hold up when we're dealing with infinity.
I mean, that's a pretty bold claim.
Yeah.
I'm intrigued, but also, I have to admit, a little skeptical.
Yeah.
How can something as fundamental as the order of addition suddenly become relevant? Like, what's the context here?
Well, so the video starts off by acknowledging sort of like the elephant in the room.
Okay.
Which is that you can't actually add an infinite number of things.
Right.
Not in the way we usually think about it, right?
Yeah.
So they introduce this concept of limits.
Okay.
Instead of trying to reach the end of an infinite sum, which doesn't exist,
Right.
we look at what happens as we add more and more terms. What value do those finite sums get closer and closer to?
Okay, so it's about the trend, the pattern,
Yeah.
not the final destination, because infinity is more about the journey than the arrival, I guess.
Exactly.
Okay.
And the video uses a classic example to illustrate this, which is 0.9999, that repeating decimal, right?
Right.
Think of it as the limit of adding 0.9,
Right.
then 0.09, then 0.0009,
Yeah.
and so on, right?
Mm-hmm.
As you add more and more nines,
Yeah.
you get ridiculously close to 1.
Okay.
So close, in fact, that in the world of infinite sums,
Right.
0.9999 actually equals 1.
Hold on a second now.
Yeah.
That doesn't sit right with me.
Yeah, I know.
Isn't 0.9999
Yeah.
always just a tiny bit less than 1,
Yeah.
no matter how many nines you add?
I know, right? It feels wrong.
Yeah.
But think of it this way.
Okay.
If it's not equal to 1, then what's the difference between the two? There's no number
Right.
small enough
Yeah, I see your point.
to fit in that gap.
Yeah.
This is where infinity messes with our everyday logic.
Yeah. Okay. So I see the point there, but does this mean
Yeah.
that every infinite sum has this, nice, neat value that it converges to?
That's where things get even more interesting.
Oh,
Not all infinite sums are so well behaved.
oh really?
Some just keep growing forever.
Like a runaway train.
Exactly.
Got an example?
Yeah, give me an example of one of those wild sums.
Okay, picture this.
Yeah.
1, 1, 1, plus 1, 1 plus 1, and so on. This sum just keeps flipping between 0, 1, never settling down.
Yeah.
The video calls this kind of sum divergent.
Right. Diverging from any one answer.
Yeah.
So is the key difference here that the numbers aren't getting smaller and smaller?
Yes.
Like for a sum to converge, the
Yeah.
pieces have to shrink.
That's the first rule, yeah.
Okay.
Look at this.
Even when the numbers DO get smaller,
Mm-hmm.
surprises can still be lurking.
Uh-oh.
Enter the infamous harmonic series.
The harmonic series.
Yeah.
A classic.
I know. It's the sum of 1 plus 12 plus 13 plus 14.
Yeah.
And so on, right?
This is pretty well behaved.
Yeah, the numbers are shrinking as you go.
Totally.
But it's a wolf in sheep's clothing. This seemingly innocent series actually diverges.
No way.
It grows infinitely large.
How can that be? Even though the pieces are getting
Robbery.
tinier and tinier.
This is where infinity shows off.
Okay.
It's weirdness.
Yeah.
The video uses this really cool grouping trick
Okay.
to prove it.
Right.
Essentially, you group the terms of the harmonic series.
Yeah.
So that they're always bigger than 1 plus 12 plus 12 plus 12. And since you can keep adding halves forever,
Right.
the sum just keeps growing.
Wow.
Yeah, it's mind-blowing, right?
So even when things seem to be getting smaller and smaller and less significant, the cumulative effect can still be just enormous.
I know.
It's like the butterfly effect.
Yeah.
But with numbers.
And that's just with all positive numbers.
Oh, boy.
When we bring in both positive and negative numbers,
Oh, I bet.
that's when things get really crazy.
Right. That adds a whole new level of complexity.
Yeah.
So does that mean that we can't even trust the order of addition anymore?
That's the question, right?
Right.
When all the numbers have the same sign,
Yeah.
order doesn't matter, just like with normal addition.
Okay.
But when we have positive and negative terms,
Yeah.
that's when the idea of order starts to hold real power.
Oh.
That's when we enter the realm of absolutely convergent series and conditionally convergent series, which the video dives into next.
Okay. These terms are interesting, But what's the difference between them?
Yeah.
And, for our listener, why should they care about this?
Let's unpack that right after we take a quick sip of water.
Yes, sounds good.
I have a feeling we'll need our mental energy for this next part.
Me too.
Yeah.
Okay, my mental reserves are full. Let's do it.
All right, so imagine you've got a bunch of positive and negative numbers that you're adding up infinitely.
Right.
Some of these sums are, let's say, well-behaved. No matter how you rearrange the terms, they always converge to the same value. Those are the absolutely convergent ones.
Absolutely convergent.
They're like the reliable friend who's always there for you through thick and thin.
Yeah, I like
But
it.
then there are the conditionally convergent sums.
Yeah, I was going to say, those are the wild ones, right?
Exactly.
The ones that keep us on our toes.
With conditionally convergent sums,
Okay.
the order you add the numbers in actually changes the final result.
Wait, hold on.
Yeah.
You're telling me that just by, shuffling the order
Yeah.
of the numbers, you can get a different sum?
Yeah.
That seems impossible.
I know, right? It
Yeah.
sounds crazy. But the video uses a familiar friend to demonstrate this behavior.
Okay.
The alternating harmonic series.
Oh, okay.
It's our old pal, the harmonic series. 1 plus 12 plus 13 plus 14,
Yeah.
but with alternating signs.
Okay, so it's 1 minus 12
Exactly.
plus 13 minus 14 and so on.
Yeah, so same numbers, just flipping between positive and negative.
Okay, so does this one converge?
It does.
Or does it still diverge like it's all positive counterpart?
It converges.
Yeah.
And get this, it converges to the natural log of 2.
The natural log of 2.
Yeah.
That's for our listener who might not be super familiar with logarithms, it's the
Yeah.
logarithm with base.
Yes.
A very special mathematical constant
Yes.
that pops up all over nature.
Yes, but
We could do a whole nother deep dive on that, I think.
yeah.
Maybe we should.
Total another topic, but for now, the important thing is
Yeah.
this alternating harmonic series, it's a conditionally convergent sum,
It is.
which means
Yeah.
oh boy, its value is at the mercy of the order we add the terms in.
Okay, my mind is officially blown. How
Yeah.
does that even work? Can you give me a concrete example of how changing the order changes the sum?
Absolutely. The video lays out this mind-bending manipulation
Right.
of the alternating harmonic series.
Okay.
So they start by multiplying the whole series by 12.
Okay.
Then they cleverly rearrange the terms, leaving some gaps for visual clarity, and they add this modified series to the original alternating harmonic series.
Okay.
The crazy part is
Yeah.
this manipulation results in a sum that equals 32 times the natural log of 2.
Hold the phone.
Right.
So just by shuffling the order and multiplying by a constant,
Yeah.
they change the value of the infinite sum.
Yeah.
That's insane.
I know.
How is that possible?
It's all thanks to the nature of conditionally convergent sums.
Okay.
So the video doesn't go through the full mathematical proof,
Okay.
but it does offer a helpful, kind of intuitive explanation. Since there are infinitely many positive and negative terms,
Right.
we can, game the system
Yeah. Okay.
by carefully rearranging them to force the sum to grow,
Right.
large or small as we want,
Okay.
or even make it diverge to infinity.
Oh.
Yeah, so it's kind of scary, right?
Yeah, it is it's like the infinite realm
Yeah.
has its own set of rules
Yeah.
that completely defy our finite logic.
Exactly, and the implications of this are huge, right?
Exactly.
If simply changing the order of addition
Yeah.
can drastically alter the outcome,
Mm,
where else does this infinity effect come into play?
that's a fantastic question.
Yeah.
And it's one we'll dig into a little bit deeper.
Okay.
But for now, I think it's worth just pausing and
Yeah.
appreciating the mind-bending concept we've just encountered.
Totally.
So while finite sums are well behaved,
Yeah.
they follow the rules we're all familiar with.
Right.
Infinite sums are a whole different ballgame. The order of addition, something we usually take for granted,
Yeah.
holds immense power in the realm of infinity.
Right.
And it reminds us that venturing into this boundless world
Yeah.
of the infinite
Yeah.
means leaving behind some of our comfortable assumptions
Yeah.
about how math works.
Totally. It's like stepping through a portal
Right.
into a mathematical wonderland
Yeah,
where the familiar rules of reality get a bit blurry.
exactly.
But speaking of blurry,
Yes.
the video only briefly touches on how we can actually rearrange
Yeah.
a conditionally convergent series to make it sum to any number we want.
Right.
And that part seemed particularly mind-blowing to me.
Yeah,
I'd love to unpack that a little further.
let's do it.
Okay.
This is where the real magic of infinite sums comes into play. And it might just change the way you think about math forever.
Okay, so how about we unravel this mystery?
Okay, let's do it.
The video mentioned we can rearrange a conditionally convergent series to make it sum to any number we want.
Any number you want.
How is that even possible? It sounds like, mathematical sorcery.
Yeah, it's definitely one of those mind-boggling aspects of infinite sums.
Right.
And while, the full proof requires some pretty advanced math tools, we can definitely, grasp the intuition behind it.
Okay.
So remember, the key here is that conditionally convergent series have both infinitely many positive terms and infinitely many negative terms.
Right.
And that's what gives us, the wiggle room to work our magic, right?
Right. It's that endless supply of both positive and negative numbers.
Exactly.
That sets the stage for this, mathematical trickery.
Yeah.
But how do we actually manipulate them to get the desired result?
Okay, so imagine you have a conditionally convergent series.
Okay.
And you want to make it sum to a specific target number.
Okay.
Let's say 5.
5. Okay.
Here's how this seesaw analogy that the video mentions comes into play.
Okay.
You start by adding up the positive terms one by one until you exceed your target.
Okay, so we keep adding positive terms.
Right.
Until we go over 5.
Until you go over 5.
Okay.
Then you switch gears and you start adding up the negative terms.
Okay.
Until your sum dips back below 5.
Right.
And you just keep repeating this process.
Okay.
Bouncing back and forth across your target value.
So we're using the positive and negative terms to create a mathematical seesaw?
Exactly.
It's trying to balance it perfectly on the number 5.
Exactly.
Right.
But how do we know we'll always be able to, cross 5?
Right.
Or any target number, for that matter.
Right.
Well, that's where the conditionally convergent nature of the series is crucial.
Okay.
Because the sum of the positive terms on their own diverges. And the sum of the negative terms also diverges.
Okay.
We're guaranteed to have an endless supply of both positive and negative pushes
I see.
to keep the seesaw going forever.
Right. Yeah.
You can always overshoot your target and then come back down.
Yeah.
Getting closer and closer.
Right.
Not ever actually landing on it.
So we're exploiting the inherent unboundedness of the positive and negative parts to force the entire sum,
The whole thing.
to converge to whatever we desire.
Right.
It's a powerful and slightly unsettling realization.
Yeah.
It highlights the importance of understanding these different types of infinite sums, right?
Absolutely. Yeah.
Just knowing that a series converges isn't enough.
Right.
You need to know how it converges
Exactly.
to grasp its full potential.
It's like having this powerful tool that can produce a wide range of results, right?
Right.
But to use it effectively, you need to understand its subtleties and its limitations.
Totally.
And the fact that we can manipulate conditionally convergent series in this way might seem like a mathematical curiosity.
Yeah.
But it has real implications for how we model and understand complex systems in all sorts of different fields.
That's what I think makes this deep dive so fascinating.
Totally.
It started with a simple question about the order of addition. And now it's led us to this, the profound depths of infinity and its implications for all these different areas of study.
It's a reminder that math isn't just this collection of abstract rules. It's a powerful language that allows us to describe the complexities of the universe.
Totally.
It can reveal some pretty astonishing truths that challenge our assumptions about how things work.
Absolutely. So to our listeners out there, we hope this deep dive has sparked your curiosity and maybe left you pondering these strange and wonderful ways that infinity shapes our understanding of the world around us.
If you ever find yourself questioning those fundamental rules of math, remember the curious case of conditionally convergent series, where a simple rearrangement can completely alter the outcome.
Absolutely. Well, on that note, I think we'll wrap up this mind-expanding deep dive.
I agree.
Until next time, keep exploring, keep questioning.
Keep questioning.
And keep embracing the infinite possibilities of knowledge.
Absolutely.